The next is method to find out the approximate values of square roots. Why you can't? The question comes: why you can't find out the exact values? Yes, for some numbers, for example, this square root 2 is there, square root 3. These are the irrational numbers. Once they are the irrational numbers, they cannot express in p by q. Why they can't express in terms of p by q? Whatever the decimal places in that, they are never repeat. Say, they are non-terminating. They never end decimal places. But in our understanding, for our convenience, for easy calculations, all those things, for example, square root 2, we can restrict the decimal places like up to three three places or four places. They are never repeat, they never end. Okay, therefore I can say for these we have to find out the approximate values. First step, we have to decide which places or three places or four places to which the square root of a number is to be computed. Call this one as a n. If you want to, here I want to find out, for example, I want to find out the square root of 2 up to 3 decimals. N is equal to 3 here. Okay. Next, if I make 3 here, count the number of digits in a decimal part. See here, this one is very important step. Next important step is eight. Just a minute, 8. Okay, but we have to think of a 3 decimal. N is equal to 3. I will definitely agree. But while doing the long division process, you have to find out the square root up to 4 decimal places. Therefore, you have to count the number of decimal. The given number is 2 here, decimal digits. To make it the 2 into 4, 8 decimal places you can make. 1, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8 decimal. Then I fix the suitable number of zeros at the extreme rate of decimal part to make it 8. You just double the, what you have to double? You decided 3, but for long division process, you have to work out the n plus 1 the decimal places of decimal. Then you make a round it to 3 decimals. But once if you decided to do the long division process for 2 up to 4 decimal places, you have to double the number of digits in a square root 2. Decimal places in double it, that is becomes 8. Okay, now start long division process of this 2 up to n plus 1 means what? 3 plus 1, 4 decimal places of it. Simply you can group separately the integral part and decimal part in a group of digits. This is 2 is a first period. 1 into 1, 1. Then subtract it 1, it becomes 1. To bring down the next period, that this becomes 100. Now double this digit 2. Next you 24 into 4, that is 96. The remaining is 4. You bring down the next period, that is double 100. Next you double this 14, that's become 28. 281 into 1, that 281. You subtract it you get 119. You bring down this again next period. This 141 you double it, you don't consider point here. 141 here, as long as here, why I'm putting decimal point, as long as the integral part is over, exhausted, you have to put decimal point. That is, keep in mind. Just 141 you double it, that becomes 282. 2800. If we fix the 4 with this digit, which is also next digit of this 141. 2824 into 4, that becomes 11296. You subtract it, you get 604. Bring down this last period. Next you double this 1414, it becomes 2828. We fix the next digit 2 with this 2828 into 2, that becomes 56564. That balance, the remainder is 3836. Now we get a square root to n plus 1 decimal place. That is 3 plus 1 means what? 4. To check the digit at n plus 1, that is 3 plus 1, that is 2. You check it here. I will write here square root of 2 is to 1.4142 at n plus 1. If it is less than 5, is you can delete this n plus 1. This, if you delete it, you can make 1.414, correct it to 3. If it is 5 or more than 5, increase the digit at nth place. See, this is n. If it is, for example, if it is 1.4146 is there, then you increase, this is n plus 1th digit, this is nth digit. Okay, increase the nth digit, at nth place by 1, means we have to make it 1.415 can make 1.415 we can make. Okay, like that. Is it 5 or more than 5, you can do it. Like this, you can work out the decimal places by doing these things.